Hello, everyone, and welcome to another edition of our Aquarium Online Academy. My name is Amanda, and I'm coming to you live from the Aquarium of the Pacific in Long Beach, California. Now, right now, I'm standing in front of one of our exhibits here, our Amber Forest exhibit, or what I should say is I'm standing in front of what looks like Amber Forest. I'm actually in a studio right now, and my friend Stacy is helping project these beautiful images on the screen behind me, and will be helping with some of the technology we'll be working with today as we discover the Earth. Now, I also have another friend here, Allie, who is sitting at the computer, who is ready to answer any text questions or relay any of those questions over to me during this program so that you can participate along with us as you're watching. So you can text your questions to 562-286-1838. Just make sure you have permission to do so, as text messaging rates may apply. Now, if you are watching this at a later time after this program has aired, you can also email us any questions you might have at the email you also see on your screen at live@lbaop.org. So let's go ahead and get started and discover the Earth. So today what we're going to be doing is looking at our Earth because it is so complex and there are so many systems working together. Now here at the Aquarium, we focus most of our attention on the Pacific Ocean, its inhabitants, and its ecosystems. But the Earth itself is very important for shaping the life in the ocean, and it helps us to understand the Earth, this planet that we're living on, and seeing how things on land and in the ocean are interconnected. And we are going to be using the help of a very special app from NOAA. Now, NOAA is NOAA, that stands for National Oceanic and Atmospheric Administration. And they have created this incredible app that you can even download yourself on your phone or a tablet and learn more about the Earth. And so we're going to use that app today to look at the Earth a little bit. Now, I'm going to be asking you to make observations. I would love to have your feedback because, of course, I can just talk a lot, but I would love to hear what things you're noticing and what you're observing. So again, feel free to text us at the number you see on your screen to let us know the things that you're noticing about our Earth as we discover the Earth. Okay, so I'm going to be using an iPad to help control what you'll be seeing on your screen here. So we're going to start by looking at what's called a data set. So data, what is data? Data is just simply information. And what we're going to be doing is looking at information not with numbers and letters, but rather in a visual way. So we're going to be looking at what the visual images we're seeing could be telling us. So some of the things you'll be seeing might look familiar to you. Some of them might look totally different, and that's okay. We can look at it together. In fact, who knows? I may even pull up a data set I've never seen before, and we can discover it together as we learn about the Earth. So let's go ahead and check in. We're going to pull up what I'm seeing on my iPad right now. So this is a data set, and it's called Earth in True Color, and it's playing right now. So let's go ahead and get familiar with this screen. So this is the Earth, right? And I'm going to have you make some observations and tell me what you notice about this image. But I also want to note that it is playing. There's this little record button here. So this data set has a specified amount of time that we can see playing over and over again. And then there's also a counter up there that will tell you the date that this data set was taken. Now, when I say the date this data set was taken, how are we getting this image? What is this coming from? We did not just magically create this cool looking thing to put up on the screen. So how is this image coming to us? Any idea? Go ahead and text us in if you know. And also, I want you to note what is happening. There's a lot of movement here. What kind of movement are you seeing, and why do you think you might be seeing it? What about the colors that you're noticing? Do you see any colors in this image or in this one? Well, we're looking at the Earth at different times that you can see right up here. So this is telling you the actual date that this was taken. But again, how was it taken? Well, maybe recently you were watching some really exciting stuff that was happening in the news about some astronauts going out into space. And so this might be the view that they would get. This is a very different view than we have down here on Earth. As we're walking along every day, and we might look up at the sky, see the clouds, but if you get past those clouds and you're looking down at Earth, this is the type of view we're getting. Now, this was not taken necessarily from astronauts just staying in one place over time. What are the other things that are out in space that could be giving us these images? Well, you guessed it, satellites. So there are satellites all around our Earth that are getting information for us and looking at the Earth with different sets of eyes or different lenses. And so I want you to think about what they were seeing here. Now, as you notice, it gets dark and then it gets light, and then it gets dark and then it gets light. Why do you think that is? Obviously, daytime and nighttime. So it looks right now that the Earth isn't moving, but what's really cool about this app is I can take my finger and I can make the Earth spin. And so this is a really neat way to explore what's going on around the world. Of course, we get to this part and we're not seeing the change. So this is what the Earth would look like if we didn't have the clouds, if there wasn't any image of those clouds moving, if we could just take all the distractions away and just look down at the Earth, this is the type of thing we would see. And what do you notice on this side? Now, normally, if this data set went all the way around the world, we'd be able to see everything. But this is kind of nice for us to look at it just in this sort of still way. Notice the colors. You see blue, and you see green, and some brownish sort of areas in different parts of the Earth. Now, where are you seeing them? And what stands out to you about what color you see the most of? Obviously, this blue area, right? And do you know what ocean it is that you're looking at here? Well, let's keep going around the world. There's Australia right there. And then we get to where it's a little bit harder to see again because we have all this activity going over the Earth. Well, we were looking at the Indian Ocean back there. And if we were to go back again, we can rotate it around a little bit more. What ocean would be over here on the other side of Africa? Do you know? What if I laid it out here? Oh, that might look a little confusing. Maybe we won't do that. That would be the Atlantic Ocean. And then, of course, on the other end, right up in here, would be the Pacific Ocean. Okay. And Sophie, thank you for following along. Sophie says satellites. You're right. We are getting these images from satellites. And the way we're getting them is very interesting because notice in the daytime it's lighter, but at nighttime it's dark, but we can still see these clouds. Now, how would a satellite be able to pick up white clouds at night? Well, it has to do with the lens that they're using to get these images. So what this satellite is programmed to do is actually sense the temperature using infrared. So they're using heat, basically, to determine where these clouds are. And the other thing that's happening is we're using kind of like this model that you see over here, where we know where the land is, and we're just kind of placing it there to give you some sort of idea of where these clouds are over our planet. But the satellites are projecting these images from these infrared sensors that are allowing them to sense the heat all over the ocean. We can overlay it over our planet. So are there any things that you notice that are interesting? Let's go ahead and look at where the United States is. And we can zoom in a little bit. Oop, might be kind of hard to zoom in. I think I just twisted our planet around. Well, as you look at this, oh yeah, we can see it's swirling. Ooh, this is kind of fun. You get to play with the planet and turn it upside down. All sorts of fun things with this app. Let's see if my hands can adjust. It's really hard to see. There we go. We're definitely upside down. Now let's try to turn it back. Okay, so there's our Earth out in space. So did you notice anything interesting? So daytime and nighttime, we can still get the images, but what is moving in here? Well, we're definitely seeing clouds. So we're seeing a layer of clouds. We're not really getting a good view of the ocean, though. So what if we look at a different data set? And let's go ahead and look at, it might not be quite as colorful, but it might give us a better look at sort of a still Earth. So we're going to look at this right here once it loads. So this picture looks very different. We're not using color in the same way here. We're using the color gray, and the darker gray is representing the ocean, and the lighter gray is representing the land. But are there any things that you notice about the land or about the ocean as I kind of move this around? Do you notice anything? Look at the oceans. Does it all look the same in the ocean, or do you notice anything? I'm going to keep moving. Oh, coming up just above Australia here. Look at that. There's some interesting shapes in the ocean, aren't there? But this would normally be all covered underwater. Now there's Hawaii right there. You can see Hawaii kind of sticking out in the middle of the Pacific Ocean, all of those islands. And then we come back over to where we are in California. But look at this area of our country. What do you see a lot of here? What are all those little lines? Yeah, those are rivers. And so two very important rivers here, actually. The Missouri River, which is the longest river in the United States, and it leads into the Mississippi River, which empties into the Gulf of Mexico down here. So what we're doing on land can make its way all the way down to the ocean, even if you live up in Montana or someplace that is not very close. Now, what's also really neat about this is maybe you're looking at this thinking, I'm not used to looking at our country like this. Doesn't it usually have the lines? Like, where exactly does California end and Arizona begin? Well, let's go ahead and put on an overlay so you can see those lines. And we'll do it like that. So look at that. So even up here, there's a river this doesn't look very close to the ocean at all. And yet it can carry things from land all the way down into the ocean. Now you might think, well, is that really the ocean? That's just the Gulf of Mexico. Is that the same thing? Well, let's look at how the oceans are connected around the world. So there is space right here, right? This is part of the ocean. It's just kind of a sort of sectioned off part of the ocean. Then you've got the Atlantic Ocean. And wait, the Atlantic is on this side. The Pacific is on this side. Are they completely separated, or are they connected in any way? Well, we can look up at the top and we can see there's Alaska right here. And it looks like there's space where that water could get all the way up here. Except up here in the North Pole, there's something interesting. It's frozen, right? Most of the time this is solid. But yes, there is water flowing from here up here, and from here down there. So those are connected. They're not completely separated. And then what about down here? Oh, look at that. There's actually this space right here where the water from the Pacific Ocean could make its way over here to the Atlantic Ocean. So we always think about the oceans as being very separated by land masses, but they aren't completely separated. There are ways that that water gets through. And even the Indian Ocean and the Atlantic Ocean, big space, and also back into the Pacific Ocean again. So all of our oceans are connected. There's nothing really distinguishing them. But now look at the ocean again. We know that the Earth is covered with water, and underneath the surface of that water, there's more going on. Did you happen to know or notice any of those marks? See some of those lighter parts, like down here by Hawaii. Remember, Hawaii, those are islands coming up from the ocean. Well, what do you think this is? Well, what you're looking at here is basically bathymetry. So you've heard of topography before. Topography is how the land is formed on Earth, like the land that we're used to seeing, the mountains. So you can see the topography. You can see that there are mountains right up here in Canada and into Alaska and down here. But also in the ocean, there are mountain ranges. There's also trenches. And we can see a little bit of that, with this particular data set. Now, even more interesting, we've kind of seen what it all looks like kind of without the water here. But let me also show you, there's another data set here, and bear with me as I try to find all of these, that will show us what it would look like if we were to imagine a big drain at the bottom of the ocean. And if we were to see what it would look like if we just slowly drained it. So I'm going to play this data set. Now, right now, we're used to seeing that blue water. But let's go ahead and drain and see what happens. Let's go over here. Ooh, now we can see the white, some of that frozen area. Now, as we start draining it, right there, see how these areas around the coast suddenly were uncovered with water? So imagine there's a little drain at the bottom of the ocean, and somebody picked up that drain, and all the water is draining down. Over time, it didn't take very long at all before all of this land was exposed, because we have what's called a continental shelf, a very shallow extension of our land going out into the ocean. But now, as time goes on, you can see these areas are still really deep, but we're starting to get these mountain ranges in the middle of the ocean. So if we were to pause it right here, if I can, and look around at the Earth would look very different. Imagine these being covered in green like all the other parts. So our land is now exposed. So this would tell us a little bit about how shallow and how deep parts of the ocean would be as we're draining it. So the areas that are still covered with water, you're going to see being very deep. Now look at this. There's a big ridge here. So these are mountains. And let's keep playing. And the average ocean depth is about 2 miles deep. And so we've already gone below that. But it can also get deeper. Okay, so as it's draining, look for the area that you think might be the deepest part. Do you know where it is? It would be the last area to drain. Here we are in the Pacific Ocean again, this whole region. But there's still some water in some places. But look at this. Do you see this area right here? That ridge, which is just off of Japan and Guam, is actually the deepest part of the ocean called the Mariana Trench. So I'm going to speed this up. We'll look at that as it's draining again. So this little ridge is the trench, but I want you to think about what makes that trench. Why are these mountain ranges and these trenches in the ocean? What's causing them? The Earth. Let me show you another data set and see if you can figure out what this might be trying to teach us or what we can learn about the Earth in this data set. Now this is called the age of the seafloor is the name of this data set, but I want you to look at what stands out to you in this. What are the words that you see? Philippine plate, Pacific plate, Juan de Fuca plate, North American plate. What are all of these? All those lines, African plate, Arabian plate, up here, the Eurasian plate. Well, these are all the tectonic plates that the Earth is sitting on. Now, they're always moving, and as these are moving, what happens? Think about what happens when the Earth is moving. There's a few different things that can happen. As those plates are coming together, they might form mountain ranges. If they're ramming into each other and one goes really deep and one goes over the top, it might cause a deep trench in places. And so where we're seeing these ridges and places in the ocean would be areas where the land is moving. And what do we call that when the land is moving? Earthquakes, right? When we can feel them. Those are earthquakes. And so where do you think the earthquakes might be happening? If we look at this data set, can you make any predictions about where the earthquakes might be happening now that you're seeing where the plates are? Oh, look at California here. This is kind of interesting. Look at that, right along the edge of a plate. And California is known for having a lot of earthquakes. Let me see if I can show you another data set of earthquakes. Would you like to see earthquakes happening? Let's see if you can figure out where they might be. Okay, so this is a data set of earthquakes from 2001 to 2015. And what's really neat is once it happens, it will shrink down to a smaller size and show you so you can see where earthquakes have happened over time. Now, it's going really fast. So you can see all these spots. Each one of those little dots that you see is one earthquake. Now, notice not all the dots look the same. Some of them are bigger and some of them are smaller. Now, if I rotate the Earth around, you can definitely see there are some that were bigger. But do you see any patterns for where these things are happening? Oh, look at those colors. Why are they so bright? Do you see any evidence on the screen of what might be causing those colors? What do those colors represent? Looks like really pretty flashes, right? Do you see anything else on the screen that would represent, whoa, did you see that massive one right there? That was really big. Why was that one so much bigger than the others? Do you see this thing down here? It might be hard to read because the lettering is really small, but it says earthquake depth, and it's showing you these different colors. And the shallowest ones in the Earth that are closest to the surface are red. And then it follows the colors of the rainbow as it goes deeper. So the deepest ones are down here, and it's about 500 kilometers is what they're in. So it's measured in kilometers. That's how deep it is. And Sophie, also following along, said that earthquakes cause the mountains in the water. You're absolutely right. And so here we can see areas where earthquakes might be happening, but also where trenches could be forming. Now, the size is actually hidden over here on this side. So the size of those dots is representing how big the magnitude of that earthquake was. So the really big circle, like there's not too many of them, but there was a really, really big one, is the magnitude 9. And then when they're like this size, it's a magnitude 8. That's a pretty big earthquake. 7 is a really big earthquake too, but 9 is even way bigger. And so those bigger shapes are those bigger magnitude earthquakes. Now, look at where they're all happening. Do you see where they're all occurring here? Do you see any patterns? Absolutely. They are going in these little lines. And do you remember when we said we were looking at Africa and we said it was on the African plate? Where do you think the boundaries of the African plate are? Yeah, you can almost see them drawn right in here. It's pretty neat. So we can see our Earth is alive and lots of earthquakes are happening all the time, all around us that we don't normally feel. Now, many of them are shallow, some of them are deep. But think about what happens to the Earth and to the ocean when an earthquake occurs. Well, there was a pretty big earthquake that happened in Japan back in 2011. And so, here, let me stop it real quick there. So back over here, and to make this a little bit easier, I'll go ahead and put an overlay on so you can see the borders. So, of course, it's covered in earthquakes. So this is a very big earthquake activity zone, right? And so Japan, right here, there was an earthquake that happened in the water off the coast of Japan that was very, very big. And what happened when that earthquake occurred? Besides just shaking all the land, it also shook the water. So a tsunami resulted. Now, think about a tsunami. It's a wave, and waves travel. And they travel in all sorts of different directions. Well, do you know how far that wave from that tsunami traveled? Now, backing up just a minute, an earthquake that causes a tsunami, a few things need to happen. First of all, it needs to cause a vertical movement. It has to be a vertical movement of the earth, causing that water to be pushed up. It also has to be pretty shallow, so not one that's really, really deep in the earth, but one that's closer to the surface. And it also has to be a really big magnitude, about 8.0 or higher. And so when those things are all working together and close to shore, we can get tsunamis. So how far do you think that tsunami traveled? Do you have any idea? Let's see. Let me pull up a data set that we have of that earthquake. As it loads, let me get this. Let me pause it for a second here. Okay, so it's going to orient you to where Japan is. So again, it's in the Pacific Ocean, and there it is. Now, what we saw was the earthquake and then the start of the tsunami of these waves. Now, the different colors that you're seeing are representing the height or the crest of the wave, of the tsunami wave, and then also blue is the trough, so the lower end of the wave. So I want you to think about how far it traveled. Now, as we look at the Earth, let's go ahead and put some more colors or some boundaries on there just to help us understand what we're looking at. So, of course, we are on the far other end of the Pacific Ocean than where that tsunami happened. We're right here in California. Did that tsunami come all the way across the ocean and affect us in California? Well, okay, maybe that's a little far. What about Hawaii? Do you think Hawaii was affected by that tsunami? Did it travel that far? All right, well, just to think about it, do you think that the tsunami would have affected anyone? Oh, how about South America? Could it have traveled all the way down to South America? Okay, what about Africa? Was Africa affected by it? Could those tsunami waves have reached Africa? Well, let's go ahead and watch and see what happens. I'm going to slow this down a little bit, and let's watch that tsunami travel. Wow, it hit Hawaii, And look at this. It hit California and even South America. But what do you notice? Anything else happening here? It traveled all the way. Do you see those colors still coming through down here? It traveled all the way over into this area. And even from the other side, of course, you can't see it very clearly on what's showing now, but those, oh, probably because it stopped, but these waves traveled not just in one direction, but also around the globe, around the oceans, and it met Africa on both sides. Now, we're talking about 24 hours, 26 hours before it actually hit Africa. And yes, it did hit California. And yes, we actually had people here at the aquarium who were outside watching it when it hit, because we are stationed right at Rainbow Harbor where we can see waves that come in. And it wasn't anything where we needed to evacuate the aquarium. It wasn't that big, but we would see the rise and fall in the water of what you would normally see between a high and a low tide. But instead of over several hours, it was over the course of minutes. And so it wasn't really big. By the time it traveled all the way across the ocean, it had lost a lot of that energy, and the waves weren't as big. But it's really interesting to see how the waves are bouncing off things as they hit land. And did you notice even earlier over here, as it left, oops, sorry, this really gets a little crazy. Notice how you start getting these waves that are bouncing off land and then coming back. So some areas were hit more than once. It wasn't just one wave. But it's really interesting to see how one episode in the ocean, one earthquake, could have traveled all the way around the Earth. So we actually live on a planet that's very well connected in the ocean. And like we saw earlier, what we're doing on land can even affect what's going into the ocean. You may have even heard about the giant Pacific garbage patch and these gyres that are around the Earth that actually will capture things that are coming down from land or from us and other parts of the ocean that get caught in this sort of circular cycle where it keeps and kind of holds that trash in. And it can be not just big trash, but also really small particles of things as well. And what we're doing is affecting the ocean. And let me see. This is a new data set I haven't looked at, so we're kind of exploring this together. Really quickly, let's see. It says marine debris garbage patch experiment. And so watch as simulated particles gather in the world's ocean garbage patches pushed along by ocean currents. So the ocean currents, so this is pretty fast. So all of these would be little particles, and we want to see how the ocean is moving to see how those things, unfortunately, this does get a little blurry, so it's not your vision. It's just, I think, our data set getting trying to adjust. There we go. It got a little bit clearer. Look at these little eddies and these circular movements around the ocean. Wow. Look at how it was all dispersed at one time, but then as the ocean currents are moving, it's kind of gathering them all together and concentrating them into different areas. This is also a great opportunity to see how the water is flowing around our planet. So this is a really interesting model. Okay, and now we're back at the beginning again. But the ocean's moving. The ocean currents are changing and taking things. They're not changing, but as the Earth is spinning and the waters are being affected as the Earth is rotating on its axis, it's also taking other things entering the ocean and it's affecting them as well. So hopefully you can see by this app and by exploring a little bit on your own, which I would encourage you to look around and see how the ocean, the world is really affected. One thing in one place can affect the other. That's the neatest thing about this app, is that you're not just seeing it on a two-dimensional scale. I could try to make it two-dimensional like this, and we could see certain areas. Of course, it's going to get blurry again as we made that switch. But we can see how it's all connected. So hopefully that's something you got out of this. Well, thank you for watching today as we discovered the Earth together. And if you have any more questions or other things that you observed during this class, we would invite you to text us. You can text us, but you can also email us at live@lbaop.org. So no matter when it is that you're watching this and there's things that you're observing and noticing and you'd like to know more about, you're welcome to contact us and we will get back to you. And then also we would encourage you to check out the Science on a Sphere app from NOAA, the National Oceanic and Atmospheric Administration. Also, if you go to their website, you can learn more about the different data sets that we were looking at. It will give you information about some of the notable features, who made the data set, how they collected the information. So some of the information we were looking at was collected from satellites out in space. Some of it was collected by computers on land. Some of it was collected by buoys out in the water. And so all of this information, we're taking advantage of all the incredible technology available to us to learn not just more about the oceans, but about our planet as a whole. And hopefully we'll be doing a better job of taking care of it. So thanks again for joining us today. Have a wonderful day. Bye, everyone.